Let us discuss pigeonhole sort. Pigeonhole sort is a sorting algorithm that is suitable for sorting lists of elements where the number of elements and the length of the range of possible key values are approximately the same. This sorting technique is originated from the pigeonhole principle that states if n items are put into containers with the number of items is greater than the number of containers, then at least one container must contain more than one item. So for our example, we have here 5 pigeons and or container or 4 holes. So the number of pigeons is greater than the holes. So one container here contains 2 pigeons because the principle states that if the number of pigeons is greater than the number of holes, so the one container or hole must contain 2 pigeons. Okay, this pigeonhole sorting technique is similar to counting sort, but it differs in that it moves items twice. Once to the bucket array and again to the final destination. This is the comparison between pigeonhole sort and the counting sort. So for example, we have here our input data or we have an array A327468. So our first step, we're going to find the range of this array. So to find the range, find the maximum and the minimum value or element in this array. Then we have 8 as the max. And this is the maximum value in the array, and 2 is the minimum. So we have 8 minus 2 plus 1, we got 7. So the range of this array is 7. Next, let's set up an array of initially empty pigeonholes the same size as of the range. So we have here index 0, index 1, 2, 3, index until index 6. That is total 7 pigeonholes. Okay, so visit each element of the array and then put each element in its pigeonhole. An element array I is put in hole at index array I minus 2. So we have here 8. 8 minus 2, which is our minimum, we have 6. So this element, we will put this element in our index 6. So we put here 8. Next, 3. So 3 minus the minimum element in the array, 3 minus 2, we have 1. So we will this one will be put in index 1, 3. So in 2 minus 2, 0. So index 0 we have 2. So 7 minus 2, 5. So we will put this element in index 5. Next, 4 minus 2, 2. So this element will be put here in index 2, 4. Next, 6 minus 2, 4. So in our index 4, we will have the 6, then 8. 8 minus 2, 6. So we will have again another 8 here in index 6. So next, start over. So we have here index 0, 2, index 1, 3, index 2, 4, And in index 4, 6, 5, 7, and index 6 we have 8, 2, 8. So in index 3 we don't have any element here. Now let's put this our sorted array to the original array. So we have 2, 3, 4, 6, 7, 8, and 8. So this is now our sorted array 2, 3, 4, 6, 7, 8, 8. So let us now analyze the time complexity of pigeonhole sort. So here we have just a single loop. So this is n. And here we are finding the range, which is k. So the time complexity of this code is the big O of n plus k. So that's all.